So, pneumatics valve banks. So one feature that people love to utilize when ordering these valve banks is using blocking discs. And what blocking discs do is they can be put into the main port and or into the exhaust ports, and what that allows us to do is use two different supply pressures on the manifold. So this side of the valve bank will be at one pressure and this side will be at the other pressure. And a lot of times people will block all three ports because they are using lubrication on one side and not the other side. Now, one thing to keep in mind on these manifolds when you use blocking discs is that if you are internally piloting the valves, the internal pilot comes through the main supply port. It will then come up through this port here and down through this crevice here. It will come through this port here as well. Now this is what is piloting the valves, and it runs all the way down the valve bank. So down this hole here is running down the entire valve bank, and what happens is it actually goes all the way to the other side, the other end plate, and can then come up through this crevice, down that hole, and interfere the other supply line. So if you have 40 psi on this side and 80 psi on this side, the 80 psi will push all the way through and end up having 80 psi on this side of the valve bank rather than the 40. I'm just using 40 and 80 as an example. So one thing that you have to do in order to avoid that, if you want to keep it internally piloted, you're going to switch one side from being internally piloted to externally piloted. Now that means that this side of the valve bank is what's going to be piloting the whole entire valves. Now what can happen here is the air comes through the valve bank and comes out through here and will exhaust out this port here. So we need to put a plug on that port as well in order to stop that air from leaking out on this. Otherwise, the other fix for us to do is to actually make the entire valve bank externally piloted, in which case we would switch both screws and now since it is externally piloted, we would have to supply air to the external pilots. By all means, you can plug one and supply air to the other, or you can supply air to both sides. It really doesn't matter. But these are piloted air valves, so they need air in order to shift. If you don't have air, they cannot shift. Now, one thing I did mention is when we are using lubrication on one side of the valve bank and not the other side, the side that is being lubricated, so let's pretend this side is the side being lubricated, that is the side that I would actually make externally piloted, so that way you're not getting lubrication through the pilot lines to your valves. Does it really matter? No, it doesn't. It won't affect the valves at all, but it just keeps the valve bank a lot cleaner when you don't have lubrication running through those pilot lines. So if this side was lubricated, that's the side I would switch to be externally piloted, and that's the side I would place my plug on. Alright, so adding on to what we were just talking about and using blocking discs. So we can use blocking discs to separate the pressure from one side of a valve bank to the other side of the valve bank. Now another nice feature that Numatics has on their valve banks is this power separation. Now what that can allow us to do is at the point that we want to separate our pressure, we can also have a power separation. Now what this is we connect this to a PLC, and that will supply the power to any valves that are at this point of the valve bank and beyond. And so if there are certain safety circuits that you're trying to, like category 2 or category 1, we can accomplish that by using just this simple power cord. So we can have supply pressure separated and we can have power separated. Now this side of the valve bank is still powered and communicates through the main node, and this side also communicates to the main node, but this side gets its power from another source through this M12 connection.